Hi everybody and welcome. Today we're going to be looking at graphing inequalities. So your goal after watching this video will be able to conceptually understand inequalities, but also understand how to put them onto a graph and the shading and the solid and dashed lines and all of the small features involved with the graphing of inequalities. So to start off, kind of ground ourselves in the idea of what we're working in. Solution is an important word to understand fully today, and that's why we're going to define it. It's a value that we can replace a variable with that will make an equation true. I should say equation or inequality true. So if we're thinking about something, let's take a simple one like x is less than 4. It makes me think of, if you've ever seen, there's this movie where one of the characters goes, if you're not first, you're last. And then I think one of his friends lists out by the end of the movie, like, well, you could be second, you could be third, you could be fourth, you could be any of the options here. Well, that's kind of the idea of a solution to an inequality is saying that you're less than 4. You don't just have to be 3. You could be 2, you could be 1, you could be any of the possible values. So think about it like that example in that movie, and that's the idea of a solution, is that we could have x equals 3 because 3 is less than 4. That is a true statement. It could be x equals 2 for the same reason. It could be x equals 1. It could be x equals 0. Basically, anything that's less than 4, x can equal it, even into like -10, for example. So that's kind of the idea of when we're going through and looking at these. When you put them on a graph, you're going to see something like x is less than 4. So as long as x is to the left of 4, we're good. So anything over here could be represented. Like we said, it could be 2, 1, 0, any of the above. And that's what we represent with shading. So that's what we're working towards today, is looking at a graph and being able to put it. But whenever you see shading, it just represents the idea that, hey, it could be many different things. So we're going to shade in all of the possible options that could make this equation or inequality true. So first things first, let's just test that background knowledge. Is 4, 1 a solution to the inequality y is greater than or equal to -2x plus 1? So first things first, our xy ordered pair. Like it says in our definition, we're going to replace our variables with what we're given here. So we're going to replace y with a 1, and we're going to replace x with a 4. And we're just going to see if this is true or not. So 1 is greater than or equal to -8 plus 1, or our final answer, 1 is greater than or equal to -7. Is 1 larger than 7, or if you had a balance of 1 in your bank account, would that be better than having a balance of -7? Yes, that is true, so it is a solution. So again, that's an idea of you can spot check individual values. You'll be asked to do that, and that's just grounding your understanding in what is a solution. But secondly, we're going to be graphing today. So a couple things to note, and I would definitely have all of these notes copied down, but especially so what I'm about to write next. When you're looking at signs, when you're graphing, if you have something like greater than or equal to or less than or equal to, this means that you're going to have a solid line. That means that any value that's on that line is also included in your solution set. However, if you have just greater than or just less than, that is dashed, because anything that's actually on the line is not included because it is equal to. When you're looking at just greater or just less, it has to be greater or less. It can't be equal. Additionally, if you have greater than or equal to, you know that you're going to be basically having a larger answer, so you're going to be shading above, and less than or equal to, you're going to be shading below. So if we look at what we're given here, this less than or equal to sign, we know in this graph we're going to be shading below, and we know it's also going to be a solid line. Other than that, you're just going to graph this like you normally would. Start off at your b value or your y-intercept, and then use your rise over run. So up 2 over 1, multiple times here. And before we go and connect these dots, remember your annotations. It's a solid line, so that means that we can make a nice solid line through here. And second, it's shaded below. So the best thing you can do is draw little arrows saying that, okay, I'm going to be shading below this. And then once you do that, you can actually go ahead and shade. So, if you have a highlighter, awesome. If you just have a pencil, you can kind of scribble it in as best as you can to represent the fact that that's the area of your solution, that's where you're going to be shading. And the idea is that for this inequality, any individual value that's in the shaded area will make it true. It'll be a true statement if you pick anything. It could be here, it could be this value here, it could be here, it could be here. Any of those things, all of those things make this true. That's why we shade it. So that's the idea for today. You're going to have a few examples to practice here. And as always, any questions, feel free to send an email, send a Teams message, book an appointment. We are here to help and we want to help. I'll see you all in Teams. And as always, thanks so much for tuning in.